Hey guys, welcome back to another RASK Maths tutorial, and in this tutorial I'm going to be continuing from the previous one where I showed you guys how to solve simultaneous equations via elimination. In this tutorial I'm going to be showing you guys how to solve them via substitution. So this is definitely the most commonly used and the most useful method. Sometimes it's referred to as Gaussian elimination, although that is slightly different, but it is also essentially the same thing. Substitution is just utilizing the fact that we can rearrange equations to be in terms of one variable and then just substitute that variable into another equation to basically cancel it out. Let's see this as an example. I'm going to use 2x plus 4y equals 15 and 3x plus y equals 7. Here's our system, and we want to find the solutions for x and y. So if we were eliminating, what we try and do is we'd probably multiply number 2 by 4 and then eliminate the y's like so. But we're doing it by substitution. So what we're going to do is we're going to take equation 2, just because it has a singular y term, so it's easier to rearrange. So equation 2 is 3x plus y equals 7. Now what we're going to do is we're going to rearrange it to get y equals minus 3x plus 7, making y the subject. And then what we're going to do is we're going to go and substitute this straight into equation 1, which is going to give us 2x plus 4 times y, but we know y is minus 3x plus 7. So let's write that in, equals 15. And from here you can see this is just an equation in x, so we can go ahead and solve it rather quickly by just working that out. X is equal to 1.3. I think that's correct. Let me make sure there aren't any silly errors. Yep, that looks correct. And then from here, the nice thing about substitution is that you also get a nice equation in terms of y. So once we've figured out x, we can easily just go and substitute this straight back into this equation to give us the answer for y. So we know y is minus 3 times 1.3 plus 7, which is minus 3.9 plus 7, which is just going to be 3.1. So the solution for xy is 1.3, 3.1. I don't know why I use decimals, I just felt like it. Let's make sure that's right. So 2.6 plus 2.6 plus 12.4 is, that's 15, and 3.9 plus 3.1 is 7. So yeah, that's how you substitute. The reason substitution is so useful is because you can now use it for nonlinear systems of equations. So I'll give you a super simple one. Let's say something like x is equal to, let's have y equals 5x and x squared plus y squared equals 1. I want to make sure we get something which actually has solutions. Okay, so here's our nonlinear system of equations. Now, you'll see if we try and use elimination, it's actually just not going to work anymore, because there's no way we can scale either of these to get rid of one variable, because this has y squareds and x squareds, whereas these only have linear terms. So we're never going to be able to reduce it anymore. But what we can do is we already have equation 1 in terms of y. So let's substitute equation 1 into equation 2 to give us x squared plus y squared, but that's just 5x squared is equal to 1. And then let's expand. So 26x squared equals 1. Or x squared, or just x, is equal to plus or minus the square root of 1 over 26. And since we already have y in terms of x, we can just say y equals plus or minus 5 times the square root of 1 over 26. And there's the answer. We were able to use substitution to eliminate y in this equation, and then solve for x, and then use this solution for x to solve for y using this first equation. So yeah, thanks for watching, and that was how you use substitution in solving systems of equations. I'm just making sure we've got this one correct. Yeah, okay. So let's write down the final notes. We just want to rearrange one equation in terms of a single variable, and then substitute this equation into another equation. If we had a triple simultaneous equation, we'd have to substitute multiple times, but we'd still end up eventually with a single variable until we have an equation in a single variable. So yeah, that is how you solve simultaneous equations by substitution. Thanks for watching, and I'll see you guys in a future tutorial. Bye!